Alright, welcome. Today we are looking once again at geometric proofs. Just kind of picking up where we left off last time. This first page is basically just a review of some postulates and theorems that we may have seen before. So if we're looking at it, the first one, the protractor postulate, basically says that I can use a protractor to measure the value of an angle. 0 degrees is here. We notice the angle stops at about 146. So the overall angle is 146 degrees. Angle addition we've seen before. Remember, it says that if we take two small angles, we can add them together to form a larger angle. So we're going to use that a lot in the coming classes. And then finally, we have supplement theorem and complement theorem. So this is basically saying that if we have a linear pair, the angles must be supplementary. And if the angles form a right angle, then they must add to 90 degrees. So let's see how we're going to use this in an actual proof. Okay, so we're given a diagram. We have 4 angles. It tells us that angles 2 and 4 are vertical. And we must prove that 2 and 4 are congruent. And so we know from the vertical angles theorem that they are congruent. It's now up to us to actually prove the vertical angles theorem works. And so to do that, we're going to use a 2-column proof. We're going to start with what we know, which is that 2 and 4 are vertical angles. And we're going to use angles 1 and 3 to kind of prove that 2 and 4 must be equal. And so when we're setting this up, we need to remember that all the angles that are not vertical form linear pairs. So 1 and 2 is a linear pair. And then I want to use 1 and 4 as another linear pair. And so the reason I'm doing it this way is so that we have at least part of our angles that overlap. So I'm going to zoom in real close so we get a bunch of extra space. Alright, so when we're doing our 2-column proof, we know we're always going to start by making those columns, right? We're going to have 1 column for the statements, 1 column for the reasons. And we know that the first thing we always do when we're starting our proofs is write down the given information. So our first given statement, and only given statement, angle 2 and angle 4 are vertical angles. Again, how did we know that? Because it was given. Okay, so let's put a little line under there to separate our steps. Alright, so the next thing we want to say is that angle 1 and 2 form a linear pair, and angles 1 and 4 form a linear pair. I'm going to go back and add in the angle symbols in a moment. Alright, and so how did we know they were linear pairs? Because we know the definition of linear pair. Alright, next step. So we know from the previous page that all linear pairs are supplementary. And again, how did we know that? What rule did we use? We simply called that the supplement theorem. Okay. All right, so again, we'll underline our little rule. All right, so if angles are supplementary, what does that mean? Well, it means that their measures add to 180. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. We also know that the measure of angle 1 plus the measure of angle 4 equals 180 degrees. And that is based on the definition of supplementary. All right, so thinking about our proofs from yesterday, we know that there's a bunch of little algebra rules we can use to simplify this down. So, if 1 and 4 add to 180 and 1 and 2 add to 180, that tells us that the measure of angle 1 plus the measure of angle 2 has to equal the measure of angle 1 plus the measure of angle 4. And that is based on our transitive property. All right, so next we notice that the angle 1 is in both equations. So we can cancel it out and say measure angle 2 equals measure angle 4. Cancel it out by subtracting, so that's our subtraction property. And finally, if measure angle 2 is equal to measure angle 4, that means that angles 2 and 4 must be congruent. Based on the definition of congruence. Alright, and so then we have a bunch of little symbols that we need to add in. Angle 2, angle 4. Adding in all the angle symbols. And then finally, I need to put the little squiggle to say congruent. And that is our formal proof. Alright, so this one I believe should be a little bit quicker. So we're going to say prove that angles 2 and 3 are congruent given that DB bisects ADC. So again, we'll start with the given. So DB bisects angle ADC. And that was given. All right, from this, we know that bisect means it splits it exactly in the middle. So that tells us that angle 1 has to equal or is congruent to angle 2. That is the definition of angle bisector. Put this right here, put this right here, and I'll go back and add in the symbols later. Alright, so if angle 1 and angle 2 are congruent, next thing we need to say is that angle 1 and angle 3 are congruent. And we know this because of what we just proved. So we can say vertical angles are congruent, or we can say the vertical angles theorem. And then finally, if angles 2 and 3 are both congruent to angle 1, then that means 2 must be congruent to 3 because of the transitive property. Alright, let's go add in the correct little symbols. So we got an angle, we got an angle, angle, angle. And these should all be congruent signs. So add a little squiggle. And that is our proof. All right, that's all for today. I will see you guys next time.